Tell us your name and tell us about your project.
My name is Arno Penzias, and my project was centered on the field of radio astronomy. Now, I completed my PhD in radio astronomy at Columbia University, and there I used masers to measure and amplify radio signals in between galaxies in space. I accepted a job at Bell Laboratories in 1961 in Homedale, New Jersey, and they had just built a large antenna to detect microwaves there for an early satellite transmission system titled ECHO. And so this was all in an effort to send long distance phone calls since they were a phone company. I thought it would be perfect though to use this antenna as a radio telescope, and in the matter of a few years I got the chance as they released a new satellite system called Telstar, and it made ECHO obsolete as well as the antenna that I was wanting to use. Now at the time there was another radio astronomer, his name was Robert Wilson, who had just joined Bell Laboratories with some of the same intentions I had to map radio signals from our galaxy. So in 1963 we teamed up and began to conduct research. And as you know, we eventually unintentionally discovered what is known as cosmic microwave background radiation.
What were you guys trying to do or find?
When we were given permission to use the Homedale antenna, we intended to immediately begin our research and use it as a radio telescope with intentions to analyze these radio signals to improve satellite communication for Bell Labs. In order to do this, though, we had to first calibrate the antenna. So this involved getting rid of all detectable radiation coming from our receiver. So throughout this process, we kept hearing a static sounding noise, though, and this was where microwaves were coming from every direction. This really annoyed us because we basically did everything we could to find out the source of this noise. We pointed the antenna at New York City to rule out any kind of urban interference. We considered radiation from the Milky Way, but we knew that couldn't be the source either. And we also made sure that the pigeons that had made their home in the antenna were not causing the radiation. So we got rid of the pigeons, although it was hard, and we cleaned out all the droppings, and we found out that wasn't causing it either. Eventually, after spending months of testing possible sources, we turned our attention to any theoretical research that could aid us. And so we found out that a physicist at Princeton University, his name was Robert Dicke, had been researching the Big Bang Theory. And he had predicted that if the Big Bang Theory was true, that there would be a low-level background radiation that would be the remnant of the explosion emanating all throughout the universe. And so this very much intrigued us. So Wilson and I contacted him and explained our observations, and Dicke confirmed that our discovery was exactly what he was searching for. So we then published our observations in the Astrophysical Journal letters, with Dicke also publishing the significance of the cosmic background radiation to the Big Bang Theory.
Where did the project or experiment occur?
Well, the entirety of the project took place at the antenna where we conducted our observations at Bell Laboratories in Homedale, New Jersey. And that's where Robert and I worked at the time. And also, in fact, in 1990, the antenna where we spent so much of our time was made a National Historic Landmark.
What other significant events were happening around the world at that time?
Well, Martin Luther King Jr. Had just delivered his I Have a Dream speech in the March on Washington. President JFK unfortunately was assassinated later in 1963. The Soviet Union sent the first woman into space. Beatlemania was sweeping the world, and Kenya also gained its independence from Britain.
Who else was involved in this project?
As you've heard me say many times already in this interview, Robert Wilson and I were really the only people involved in this project and our eventual discovery of the cosmic microwave background radiation. However, we couldn't have made the conclusion that we did without the prior research of Robert Dicke and also all those that collaborated with him at Princeton University.
What was your role in the project?
Well, my role in the project was the same as my colleague Robert Wilson. We were given control of the horn antenna, and our job was to map radio signals from our galaxy, all in an effort to better understand how these signals behave in the atmosphere to improve communication. I had no idea that what we were doing would change the understanding of our universe forever.
What impact did your project have on the physics community?
Our project changed the field of cosmology for sure. At the time of our discovery, the field of cosmology was just a small part of physics, a subject that few physicists chose to research due to the futility of what you could find. So when our findings were published, cosmology really took off. And now you can see the evidence of many researchers that have devoted their whole lives to the study of the early universe. Our discovery also validated the Big Bang Theory. The Big Bang Theory at the time was kind of in debate of whether it was the leading explanation for the creation of our universe compared to the steady state theory, which says that our universe has no beginning or end. So with our observations, we really put the Big Bang Theory above the steady state theory and really validated it. And so with Edwin Hubble's findings earlier, a couple decades earlier, that he said that the universe is expanding rapidly, combined with our discovery of the cosmic background radiation, the Big Bang Theory really was validated, and it gave us tremendous understanding of our universe. Ultimately, in 1978, Wilson and I were awarded the Nobel Peace Prize for our discovery.
Why did you choose Bell Laboratories as the place to start your career?
Well, it's funny you asked that. At the time, I had just finished my thesis at Columbia, and I was approaching Bell Labs with the idea that I wouldn't be seeking a permanent job or even a permanent job as a radio astronomer. I was really just looking for a part-time job where I could continue the work I had done in my thesis. So when I was interviewed by Rudy Kaufner, the director of the radio research laboratory there, I just asked him if I could have a part-time job using their facilities for radio astronomy, and he actually offered me a full-time permanent job. And to my surprise, I took it, and I spent the next 37 years of my life there, and I'm really glad that I did.
All right, thank you for your interview.
Thank you.